And so, yeah, today I'm going to talk about server-side rendering with Angular. And so we're going to see, where it comes from, what are the different features we have available now, kind of how it's working. And of course, if you have questions, we'll do a Q&A at the end to cover all of these topics. So my name is Alain, or just Al, and I'm a Google developer expert in Angular and Google Maps. Started with Angular back in the AngularJS days, a long time ago in 2011. And I've been doing consulting and training around Angular for so many years now. And my main website and activity is Angular.training.com, where I teach Angular to beginners or advanced groups of people, sometimes in person, sometimes online, also through my blog and newsletter and some video courses that are available out there. And I speak at conferences pretty often. I've been speaking on all continents except Antarctica. So yeah, I've been all over the place to talk about Angular and web development. So that's me. Now we're going to talk about SSR, or server-side rendering. And so for the purpose of this talk, we're going to use a real app, which I often use for my training, which is store.angulartraining.com. It's a fake license plate store where you have products and you can add them to a cart. And it's an Angular application, of course. And that's what's going to be the base of our testing and the application we're going to use for this. So why server-side rendering first, right? It's important to consider, is this something I should be using or not? And what are the benefits of doing it? So before getting into server-side rendering, it's important to remember that Angular by default is client-side rendering, right? And so when we use regular Angular without SSR, the process that's going on is really like this. You load an app in a browser by typing a URL. That URL is going to send a request to a server, download the HTML app shell, which is our index HTML, which is pretty much empty, but refers to some JavaScript and CSS, which then gets downloaded. Then all of that code gets parsed by the browser and interpreted, which basically launches the Angular framework, which is then going to build the HTML DOM structure from our JavaScript code, build the UI piece by piece, render that on the screen, run our HTTP requests, like AJAX requests, right, to get data from a server, and update the DOM once more accordingly. And then at that point, the page is fully rendered. So all of these steps happen pretty quickly, usually, right? We don't necessarily realize that all of these little steps have to happen before we get our app fully loaded, but that's really what's going on. And so even if us human beings tend to not notice all of these steps, if you are a SEO web crawler from Google or anything like this, you'll see that, well, the first thing these crawlers will notice is that when they access the index HTML, it's empty. So they have nothing to index by default. And they're going to need to try to render that page later on to see what the actual content is. So there's definitely a delay in indexing, a delay in parsing the page. And so if one of your priorities is SEO and being indexed properly, that could be something that slows you down and makes things not as optimized as they could be. So that's what our index HTML looks like, right? In a regular Angular application, the only true HTML that we have is the root component, the app root. And then we have this reference to the scripts that we're going to download, runtime, polyfills, main.js, and of course the CSS. And that's it, right? That's what the browser would see by default before the application gets loaded. So in order to evaluate a web application, it's always a good idea to first take a look at what's going on. Are we doing good, or can we improve things? And one of the best tools we have out there to do that is Lighthouse. So Lighthouse is available in the browser. So I'm going to go to store.angulartraining.com. This opens the website. From there, I'm going to open the DevTools. In the DevTools, I would go to the Lighthouse tab. And in that Lighthouse tab, I can ask for a report to run an analysis of my website and get feedback from it. So I'm going to select desktop here. I'm going to ask for performance feedback, maybe best practices and SEO. So I'll include these 3 categories, and I click Analyze Page Load. So this is going to run a quick audit of my website, my Angular application. So what's going on right now is that Lighthouse is trying to load the app, simulating different network conditions, simulating what happens if JavaScript is not available, trying different screen sizes and all of that. So it takes about 30 seconds to get that report, and it's testing all sorts of things. So we see that it's loading the app, and it's going to do it quite a few more times. And from that, we're going to get a score and some feedback. So there we go. That's my score. So overall, I get 82 in terms of performance, 78 best practices, 73 SEO, right? And if I scroll down a little bit, I can get more details about why I got 82 in performance. And these scores are divided into multiple different categories: CLS, SI, FCP, LCP, TBT. If you're not familiar with those, you can scroll down further, and it's going to tell you that FCP is first contentful paint. And first contentful paint means this is the amount of time it took to display the page with the first, meaningful content visible on the page. So the user can see something that makes sense and start using the website, basically. A largest contentful paint is when basically everything gets loaded, right? The entire page is ready. I have a TBT blocking time of 280 milliseconds. That's because the page cannot be displayed before we download all of these scripts and CSS, so it's blocking before we get that. And we have a layout shift because the layout is changing as the application gets loaded. And we can see that down here in that view, where initially my page is blank. Then we have a component that gets loaded. Then we get more data and more components get loaded. And these components load their images. So the layout keeps changing on the page as we load more and more data and information. So I get a not super good score here on the layout shift because there's layout shifting on that page. And so this is usually a penalty from an SEO perspective, especially for mobile devices, because when you're on a phone, recomputing the layout and moving things around is a lot more expensive than on a laptop, for instance, because of course the screen is smaller, so there's more layout computations to be made, and on top of that, you're using more CPU, which means you're using more battery, and it's gonna impact the performance of that device. So layout shift is something that SEO, search engines don't like too much because it impacts the user experience on these smaller devices in terms of battery consumption, in terms of loading time, and in terms of all of these different things. So that's kind of what we can get from Lighthouse, right? We get all of these sorts of informations. You can get more details if you scroll down, and it can tell you all of the things you could improve one by one. So reduce the JavaScript execution time, avoid the layout shift, and all of that. So we get a to-do list of what to do, and we can even expand it. It's going to show us exactly which blocks are a problem and are shifting or whatever. So this is really good. You know, even without SSR, you can take a look at this and get a good to-do list of things to improve in your application. Now, this talk is about SSR. So why does SSR help with this? And that's our next step. We just saw that without SSR, we have layout shift, right? It's pretty much impossible to avoid because initially there's nothing to display. The index HTML is empty, so we have this blank page that would show up and then start loading things little by little. When we use SSR, the main difference, if we take that process that we saw earlier of downloading the HTML and then the JavaScript and parsing it and everything, if we use server-side rendering, the main difference is that the page is fully rendered right from the start. As soon as we download the HTML and CSS, we have everything. We have everything, and the page is fully rendered right there. So as you can tell, there's not going to be layout shifting because we already have the page with the right layout and everything on it. Which means there's no blank page. All of these numbers are automatically going to improve. They have to, because we get everything from the start. And then, of course, it's still going to happen that we download the JavaScript because it's still an Angular application. So that JavaScript still gets downloaded, still gets parsed and interpreted. And then Angular is going to take over the DOM and control future updates. So that's the process known as hydration that you've probably seen here and there in Angular. So hydration is really a fancy word for saying Angular takes that DOM and just reuses it for future updates of our components. So it's just going to take over in terms of change detection, in terms of handling events and clicks and everything. And then the Angular app then becomes just a regular client-side Angular app. So hydration is what makes that possible. So as you can tell just from that, process, it seems that server-side rendering is going to solve a lot of things and improve our performance and SEO metrics. So server-side rendering is going to help with speed, of course, because if you render an index HTML on the server, it can be cached on the server side, on the client side. And, for some websites, if you have a landing page that's pretty much always the same and doesn't really change a lot, why rebuild it all the time if it's always the same, right? You could use cache and make things faster. SEO, pre-rendered pages load faster, score more points SEO-wise. That's pretty much impossible to beat at this point since we get no more layout shifting and all of that. So all of the performance metrics improve, which helps with SEO, which helps with user experience. It's really helping with so many things at this point that especially if you have something that's very slow, that would boost it quite a bit with very little effort. Which is our next topic, right? How can we enable SSR? How do we use server-side rendering? So the first thing I would recommend is to be at least on Angular version 17, because since Angular version 17, it's a lot easier to do SSR. The only thing, so if you start a new project that's on Angular 17 or more, you can just do ng-new-SSR. And as a matter of fact, even if you don't do that and you create a project with ng-new now, Angular is going to ask you, do you want to do server-side rendering? So you're going to get that question no matter what. And you can say yes or no. If you have an existing project and it's at least on Angular 17 and you want to add server-side rendering, all you have to do is ng-add @angular/SSR. You run that command, and then you have an Angular server-side rendered project. Now, I know that sounds too easy, so I'm going to do that for you. I'm going to run the command just to prove you that it's possible. So my project is right here. So that's my license plate store project as we saw it in the browser. At this point, it's just a regular Angular application. If I open package.json, it's on Angular 20. There's no SSR stuff at all. It's just a basic, Angular project. So from there, I'm going to open a terminal, and I'm going to do ng add at Angular/SSR. So running that command, and it's going to do a couple of things, such as creating a main server.ts, app config server.ts, app route server.ts, updating my Angular JSON, TS config JSON, package JSON, and the application config. So all of these things got updated for me or created, and we see that they're showing up right there. So that's really all there is to it. This code is standard. You don't have to change it. It comes with your setup of server-side rendering. By default, this routes.server.ts is saying that all routes are pre-rendered on the server side. That's an option we could change if we wanted to, and I'll talk about that a little bit later. And in the app config, what was changed is provide client hydration with event replay. I'll also talk about that a little bit later. But that's the only change that was made here in the app config. And then we get all of these new files that got added and that do the work. Now, the funny thing is, I did that upgrade yesterday to Angular 20 to showcase this example. And when I ran ng-serve, I had the surprise that it was not working anymore. There was a little issue that happened. So I reported it to the Angular team, and they already fixed it, believe it or not. I opened an issue on the Angular repo, and it was fixed right away. And so now with the next, probably the next bug fix version, which would be Angular 20.03 or 4 already. What do we have here? Yeah, I have 3. So it would be with 20.04 most likely. That fix is going to be there. For now, I have to do it manually. So I think it is in the TS app config. That one file is missing here. And it is the main.server.ts. So I learned that from the bug I reported yesterday, basically, that this import was missing. But the Angular team jumped on it very quickly. And so now if I do ng-serve again, it should work. Hopefully. Yep, it works. And so now this app is rendered on localhost 4200. I'm going to open it. And so that's my license plate store running locally with server-side rendering. First thing you probably noticed is that everything got displayed instantly, right? It just loaded right away with everything displayed. And that's because we have server-side rendering. So we can check that. We can check that from the network tab. If I go to the network tab and refresh my page, I go to the localhost, and in localhost, what I'm going to see is that what we get from the server is not just the app root anymore, but it's the entire HTML, right? So the very first request we make to load localhost doesn't just respond with the app root, it has everything in it. So this means this was server-side rendered by the server. So that's one way to see it. And of course, if we want to see how much of an impact this has, we can go to Lighthouse, and I'm just going to do a quick run again, same things as before. And I'm going to do that run, and you'll see that all of these numbers are going to improve. Now, I'm also cheating a little bit because this is running on localhost. The previous one was the version on the web. So yeah, numbers are going to be better. And yeah, performance is up to 91 now. So that's pretty good. We got a big boost in performance just by using server-side rendering. And as we could expect, the layout shift is almost non-existent. And the first contentful paint is very good too. So we had a little bit of blank, the time to just download the HTML, but then everything was displayed. And so there was no more layout shifting at that point. So we get to a stable page a lot faster as a result, which is what we wanted, which is really the point of server-side rendering. So we saw that SSR works, improves our experience, improves our performance. And in terms of changes made to our project, there's a few of them. So hydration gets enabled automatically, which means Angular downloaded everything. The entire DOM was downloaded to the page, as we saw. And then Angular would take over that DOM and run just as a regular client-side application without rebuilding it. And that's something that was done very recently, right? If you did server-side rendering with Angular Universal, before Angular 17, it would be a destructive hydration, meaning that Angular would just take over by destroying everything and rebuilding the app in the browser, which was not ideal. That's not the case anymore. Now Angular is just reusing that DOM and hooking into it to listen to events and make things happen. And not only that, there's something that's even better that's actually happening, is that when I go to my network tab again, and I look at my localhost web page, we saw that we download all of the HTML in here. But if we scroll to the very bottom of the page, you'll see that there's some ng-state downloaded, which is JSON. And that JSON is actually a cache of all of the HTTP requests that were made to pre-render the application, which means when Angular takes over my app in the browser, if there's an HTTP client request that we make, instead of doing that request and going to the server, it's going to use that cached data out of the box. So not only are we caching the HTML of that initial render, we're also caching the data of all of the HTTP client requests that we make. And it's part of my HTML here, right? There's a script tag at the very end with all of that info. So that makes things a lot faster as well. And that avoids Angular from making those requests twice, once on the server side and then once on the client side just instantly later. So that's a nice benefit that we get as well, that all of the data as JSON is cached within our HTML on the initial render. Since I'm talking about what's happening in the browser when we render an SSR app, we saw in the app config that there is this with event replay, right? And with event replay is something that was added, I think it was initially Angular 18 and then maybe stabilized in 19 or something like that, pretty recent. And what event replay is that we download this entire HTML upfront, which means potentially a user could click on a button or start interacting with the page before the JavaScript is downloaded and before Angular took over the application, right? That could happen, especially if we have a lot of JavaScript to download and the network connection is pretty slow. That could happen, that we render that static HTML and then the user starts clicking around, and these events, they would be lost if we don't do anything. So what we get now by default, again with Angular SSR, is this notion of event replay, which means that our HTML even though it's just static HTML here, it's actually going to have a little bit of JavaScript to listen to all events. And that way, as soon as Angular gets loaded, these events are going to be replayed by Angular to make sure that we're not missing anything. So if I clicked on that Add to Cart button before the JavaScript of Angular was loaded and Angular was up and running, it would still work, because as soon as Angular is ready, that event will be replayed by Angular and do the right thing in the context of the Angular application. So that really makes our life easier, because we don't have to worry about anything really at this point. We just use server-side rendering, and then Angular takes care of pre-rendering that page on the server side. And if all of the synchronization stuff happens on the client side, whether it's events or data, Angular is just taking care of it. So that's pretty nice. What else can I say here? So yeah, the layout shift improves. So depending on the application and the network conditions, you'll see different performance results. When I created those slides a while ago, I had 88 of performance initially before SSR, and I was able to get up to 100 in terms of performance after using SSR, because again, no layout shifting, you get everything loaded up front, so performance automatically improves. So there are some things to be aware of, right? What I described so far seems like Angular is doing a lot of magic behind the scenes to make SSR a reality. But the thing is, if you want to do true SSR, you are going to need a Node.js server to run all of that. That wasn't the case before in regular Angular, right? You would just build your app, and once it is built, you just deploy your dist folder, and it just works in the browser. Now that's a little bit different. If you do SSR, you need to run a Node.js server with your server-side code. So when we build an Angular SSR app, we end up with two folders in our dist. One is server and one is browser. So I'm going to do a quick build here, just so you can see that. I'm going to stop my compiler, run ng build. ng build completed. I can go to dist. In my dist folder, you see there's a browser folder, there's a server folder. So server has the server JS code with some chunks and an index HTML for the server. So that's basically the server-side stuff. And on the browser side of things, we get pretty much our regular Angular app, with the exception that the index HTML was also pre-rendered. So that page is also pre-rendered at build time with everything in it. And all of the routes of my application, which may or may not be something that you expected, were also pre-rendered when we use SSR. So I have a cart page. It was pre-rendered as well at build time. And the checkout page was also pre-rendered by ng-build. So that's what we call static site generation, or SSG. And yeah, it is also done automatically by the build process. And also caching the data, as you can see with the ng-state script at the end. So the JSON from HTTP requests gets in the cache, if we have any, of course. So yeah, everything is pre-rendered at build time, and then we would need a Node.js server to run everything at runtime. So are there any things we have to do differently with SSR? And I saw a few questions, I think, in the chat. Hey, how do we know which APIs are available or not with SSR? Actually, pretty much everything would be available with SSR. The only things that are going to be a little bit different is that if you do browser-specific stuff, like using the window object or document, navigator, location, or some specific properties of HTML element, as you can imagine, these do not exist on the server side when Angular is pre-rendering those pages, right? It's pre-rendering the pages with Node.js, not with a browser. So if you pre-render with a Node, you don't have a window, you don't have a document, you don't have a location or none of these things. So if you use these, you have to change your code a little bit. And the solution is to use some hooks that were introduced in Angular 16 after render and after next render. One of them was renamed in Angular 20, by the way, and I didn't update my slide yet, so sorry about that. But yeah, that's the idea. You would, any document manipulation or navigator or whatever native JavaScript API that you need, you would put them in these hooks after render or after next render to get that information. And that way, server-side rendering is just going to ignore those specific hooks and not run them, so that it only happens on the client side. That's really the idea. So that's one thing to be aware of, one small difference to know about. And the other important thing, and that's going to be my last topic, because I think I'm about to run out of time, static site generation versus server-side rendering, so SSG versus SSR. So if you don't want to use Node, or you don't have access to a Node server, or your company cannot do that, cannot use that kind of hosting or anything, you can still do a little bit of server-side stuff by using SSG or static site generation. Because as we just saw, when we run ng-build, we have a pre-rendered output for all of the pages, right? And so we could still use that as our production Angular code, which means initially we would have those pages pre-rendered and more and faster as a result. And then we just don't have SSR taking over and rendering everything on the server. So the main difference is that those pages would be built just once for all at compile time and not at runtime. That's the only downside of that SSG. So something you could use if your website or web app is very static and you don't have a lot of pages to take care of, just a couple of, or everything is static and doesn't change, that would be a very good option. And yeah, it gives you some benefits of SSR, but without having to change your infrastructure to host Node.js application. So in that case, you just do ng-build, and then you serve those static files, just like a regular client-side Angular app. So pretty straightforward. And yeah, in terms of pre-rendering, you can specify which routes you want to pre-render or not. And that's something we saw in that app route server. So here, everything is set to pre-render, but there are other options. So if I wanted some routes to be rendered on the client only, or on the server only, or pre-render and then take over, you have these options here that you can decide. So you can decide, oh, this path, so here everything is pre-rendered, but I could decide to make exceptions for some pages that are very dynamic and don't need to be pre-rendered because the pre-rendering would not mean anything. Or on the other hand, we can say, oh, these ones are super static. We can pre-render them on the server side. So you can fine-tune that config route by route in this app route server.ts. And so, yeah, that's everything I can say about SSR in just 30 minutes. Just one last thing, which is the Angular certification program. That's something that I run with certificates.dev. So if you're an Angular developer and you want to showcase your skills, feel free to check out certificates.dev/Angular, and you'll see all of these different certifications offered to you. They are maintained by GDEs. They are very serious. We take things very seriously. We do proctoring and code challenges. It's not just a quiz. It's actually pretty difficult. And so it has a lot of value on the job market these days. And a lot of companies are using those in Europe, in Asia, and in the United States. I added some links to my blog, my slides, my free Angular newsletter. And now I think we can cover some questions.
Yeah, thank you, Alain, for your awesome presentation. There is already like a lot of questions regarding the SSR. You have been talking about your courses, and I saw just one question was regarding the courses about the SSR. So does your courses cover it?
So in terms of training, right?
Yes, right. The training.
So that's something I cover. So not only in my online stuff, I do have a course on LinkedIn Learning, which is about Angular performance. And that course does have a few videos on SSR. So that's on LinkedIn Learning, and there's some good content on SSR that allows you to dive a little bit deeper. So that would be the place to go to, yeah.
Okay. There is another question from Arthur. Is it possible, reasonable to make SSR PWA if I would like to support offline mode and mobile-like desktop app experience?
Yes, that's something you could definitely do, and seems like a good use case. I would even say that, you know, if you do SSG, since everything is already static and pre-rendered, you pretty much you don't even need the PWA side of things anymore, or not as much, only to accept the further HTTP requests you might get in the future and catch them and do something like replay a cache or do that for full support of offline mode. But yeah, it's definitely a good combination to consider to have to be able to do offline. Yeah, makes things easier for sure.
Okay. There is another question from Mugatu. How do we check if a specific API is available on SSR?
Yeah, so that's a very good question. I would say try it, do the migration, test things, and see if it works. As we saw in one of my last slides, the only exception are really manipulating document or navigator or these native APIs. So if you're using a library that doesn't do that, it should work by default, right? There should not be any difficulties. If the library didn't do that work of using these hooks to manipulate the DOM and access those objects within those hooks, then it might, the API will not work by default, and the author would have to either fix that, or you would have to find another option, basically. But yeah, because it's so to make the switch, I think that really most APIs should be available on SSR. Within Angular, everything is, for sure. So that's not a problem. It's only if you use external libraries that maybe some of them didn't do the little bit of work to cover that transition. But yeah, from my perspective, it should be like 99% should work on SSR no matter what. Yeah.
Okay. There is another question from Arthur. When you generate SSR app, are the pages rendered during the build time or once the user requests the page visiting the app's URL?
So both, right? We saw that when I run ng-build, it's going to create a static pre-rendered version of the page. And then in the browser, when we navigate, it's going to load that by default and then take over with Angular on the client side and possibly refresh that page if needed. So it's really a mix of both, and various pre-rendering at build time, and then taking over in the browser using the re-rendering in the server once we have loaded the application in the browser.
And one more question from Arthur. Will every replayed event trigger sync change detection, or those events are somehow coalesced?
So I guess that would be in a case where someone clicks 5 times on the same button. Do we trigger 5 click events or just one? That's a good question. I'm not sure. I haven't tried it. I would say it would trigger the 5 events consecutively. If you do like 5 clicks, it would just do the 5 clicks. And then the Angular application would react just the way it would, if the user does 5 clicks on that button on a regular client-side app. So I don't think there would be any difference from that perspective, but again, something to double check just in case. But I don't see why they would have made it any different.
And the last question from the Łukasz: how to handle first-time requests for a route that is not SSG generated? That is not SSG, not SSR.
Yeah, so what's going to happen in that scenario is that, the Angular router is going to handle that on the client side. So it's going to see, oh, I have to go to that component. It's going to change the URL, and then there's no server-side index HTML returned. So Angular is just going to load the component and work like the Angular we already know. So there's just no difference in that case. It just like regular client-side Angular if there's no SSR pre-rendering or SSG done, right? Just falls back to what it already knows.
Okay. So Alain, that was the last question I bring on. There is like plenty of questions. So if you have a while, it will be great if you can jump to the chat and maybe answer some of them, because there is like SSR is the hot topic, a lot of questions, but also we have to go on. So that's it. So thank you again for being part of our meetups. It's like the second time, and I hope to see you again in the future. So
yeah, no problem, my pleasure. Thanks for having me, and thanks everyone for your questions.
Okay, have a nice day.
Yeah, thank you, you too.